Imagine for a moment the vast, silent expanse of Mars. Red dust stretches to a horizon that seems to curve just a little differently under a sky that holds a perpetual twilight. Now, in this utterly alien landscape, picture something truly audacious, a helicopter. Not a rendering, not a concept, but a real spinning, flying machine. This isn't the stuff of science fiction, though it often feels like it. This is Ingenuity, the Mars helicopter, a marvel that hitched a ride across 300 million miles of cosmic void tucked away beneath the belly of the Perseverance rover. For all its incredible journey and potential, Ingenuity itself is remarkably small, weighing in at a mere 4 pounds. It's essentially a 4-legged flying camera, a whisper of technology sent to test the very limits of what's possible beyond Earth. More than anything else, Ingenuity is an interplanetary test flight, a grand experiment in extraterrestrial aviation. Its chief purpose, its monumental task, is to prove that flight is even conceivable in Mars's incredibly thin atmosphere. And when we say thin, we mean it profoundly. The Martian atmosphere is less than 1% the density of Earth's. To put that into perspective, flying a helicopter on Mars is akin to flying one at over 100,000 feet here on Earth, an altitude far beyond the reach of any terrestrial helicopter. This isn't just a challenge, it's a feat that demands exponentially more lift from very little air. To overcome this monumental hurdle, Ingenuity is a masterpiece of specialized engineering. It features 4 specially made carbon fiber blades arranged into 2 sets of rotors. These 2 rotors spin in opposite directions, a common design for stability. But what's truly extraordinary is their speed. They churn the wisps of Martian air at around 2,400 revolutions per minute, many times faster than a helicopter on Earth would ever need to spin. It's an almost frantic ballet of blades designed to claw at every available molecule of that rarefied atmosphere. But the thin air is only one piece of the Martian puzzle. The cold presents another formidable challenge. Mars is a frigid world, especially at night. Temperatures can plunge to a bone-chilling -90 degrees Celsius. This extreme cold pushes the tolerability limits of every single component within Ingenuity, from its delicate electronics to its power systems. Protecting these vital parts, keeping them warm enough to function and survive, requires significant power, adding another layer of complexity to its design and operations. Then there's the immense distance. Consider for a moment the sheer separation between Earth and Mars. It's impossible to control Ingenuity in real time, to steer it with a joystick as you might a drone in your backyard. Command signals can take many minutes to reach Mars, making instantaneous control an absolute impossibility. While the Perseverance rover moves deliberately along the ground, with engineers carefully planning its every turn, a flying instrument like Ingenuity requires a different approach entirely. This little helicopter has to be remarkably independent. It receives its orders in advance, a carefully choreographed sequence of instructions uploaded from Earth. Once those commands are received, Ingenuity largely takes off and executes its flight plan on its own volition, a true autonomous pioneer. It's also responsible for autonomously charging itself using its solar panel, a crucial task that Perseverance, with its novel nuclear battery, doesn't need to undertake. Ingenuity's reliance on solar power further emphasizes its self-sufficiency, turning every Martian day into a race against the setting sun and the encroaching cold. As if being the first object to achieve powered, controlled flight on a distant planet wasn't enough of an epic accomplishment, Ingenuity has another crucial task: surveillance. The copter carries a high-resolution, downward-looking camera. This camera isn't just for its own navigation. It's a pair of eyes for the slow-moving Perseverance rover. Ingenuity can survey the ground immediately over a hill or peek into a crater that would be too time-consuming or risky for Perseverance to approach directly. It acts as an aerial scout, extending the scientific reach of the mission in ways previously unimaginable. Ingenuity represents not just a technological triumph, but a triumph of human spirit and ingenuity. It's a testament to our insatiable desire to push boundaries, to ask what if, and then to build the answer. This small 4-pound marvel spinning its way through the thin Martian air isn't just flying, it's redefining what's possible. It shows us that with enough determination, enough precise engineering, and enough imagination, we can indeed fly the impossible. It's a delicate, daring machine, paving the way for future aerial exploration, opening up a whole new dimension of discovery on other worlds. What do you think the future holds for aerial vehicles on Mars and beyond? Could we see entire fleets of scout helicopters exploring canyons and mountains from above? Share your thoughts in the comments below, and let's keep the conversation about this incredible feat of engineering soaring.